So 3 sine, 2 sine of 3 theta. And I changed my window to go from negative 3 to 3 on all directions because I knew my radius was 2. That being said, I want to trace. I need a counter. Who's a really good counter? Excellent.
I counted to 900 one guy.
Yes! Sam, let's go count.
That's 15 minutes.
He was counting down the time to the class.
That's impressive. No, Sam has got an impressive focus in certain things. There's something interesting about that. Sam, ready? Count them. How many petals? I want you to tell me when I'm done drawing 3 petals.
Those little circular things.
All you have to tell me is when I'm done tracing out 3 petals. Ready?
Done. There's 3.
Now, trace, this is mind-boggling, but trace, you always hit the right arrow to move forward in theta, and then you hit the left arrow to go back in theta. It's not directionally left and right. It's just, I'm advancing my theta. Check this out. By the way, I changed my second zoom. There's this thing called second zoom or format. I'm using polar coordinates in there rather than rectangular. So if you go second zoom and do polar, what you get to see is when I hit trace, it puts in r and theta as opposed to x and y. It gets rid of the x and y and gives you just r and theta. All right, Sam, I'm going to tell me how many petals I've traced. Tracing, I'm tracing. Tell me when I'm done. I traced out 3 petals, done. How many degrees did it take me to trace that out? Pi. So this traces in 0 to pi. I didn't have to go 2 pi to trace it out. Only 0 to pi. Okay, coolio. By the way, let's go to the next one. Petals. Now, Sydney, you told us something about the petals in this one, that it's not going to be 4. How many is it going to be? 8. When there's an even number, you get twice the petals. Okay? The maximum radius or the petal length is, we'll go with petal length because that's fun to talk about. Petal length is 4 because that's the number up front. Got that? Traces in, here goes. We're going to go in there. We're going to rock this. We're going to put 4 cosine, or 4 sine, I'm sorry, of 4 theta, right? Or is it supposed to be cosine? And number 2? Yeah, let's go cosine. 4 theta. We're supposed to have 8 petals. No, we aren't. It's going to have 4. Watch. Oops.
It looks weird on these calculators.
Well, gosh. These are so hard on my calculators. It's not all about appearance. We need to talk about what's inside. This calculator has a heart and soul. There you go. You ready to count? Let's trace. We're going to count out. We got to trace out all 8. Now, I promise, we're only going to count half of them out of here. There's half of 1. Let's count them out loud. Got 2 down. We're on to the 3rd. 4th. 5th. 6th. 7th. 8th. And the extra half because I only started at the top. Did we finish, Sam?
Yeah.
How many degrees did it take to trace that baby out? 2 pi. So this traces in 0 to 2 pi. Are you ready for the mnemonic? Do you know what's cool about an even number of degrees? You get double the petals in double the time. When you have an even number of degrees, it's double petals in double time. Takes 2 pi. If it's even, twice the petals, twice the time. Bam! Moving on.
It looks so cold.
No, it isn't. Next one. 4 versus
Why did the sun already set?
5. Don't let the sun go down on me.
That's the shit I really
Well, that is really not a good time. No, no, we are not doing team restroom
We
trips.
sure are.
Let's
Let's
go.
go.
Beforehand. Oh wait. Ah, come on. No.
All right. Last piece. What's the difference between? Oh, dope. This is a quick one. We don't have to graph it. This is just details. Number 4, petals. How many petals? 3. Okay. Bestest petals is 3. What's the radius of my petals, or what are the length of those petals? Length of the petals? No.
It's not too bad.
Length of the petals?
1.
1. Whatever number's up front describes the length of the petals. Cool, Kelsey, you with me? You with me?
Yeah.
Okay, okay.
-2 on number 5.
Now, whoa, hold that. What's the traces in
2 5.
0 to pi.
0 to pi? It's an odd 0 to pi, don't guess. So this is odd. When n is odd in the rows category, we get the exact same number of petals. The length is determined by whatever coefficients with the cosine. It traces in 0 to pi. You go even on me, then it changes. What do we got for petals? 4, 2 times that many.
What?
Length,
What was the one with 8? That's where my answers
length.
are. -2.
Okay, we're just gonna go with 2, but yeah, -2 is an implication. Traces. Come on, Sam, another wrong one. Give me another one. Traces in.
0 2.
Dang it, you got it. I'm just kidding. Good job. Good work. All right, 2. Double the petals, double the length. What does the negative have to do with anything? It just flips it. Let's go flip all these over, one at a time.
But we're on the rows.
It does the same thing. Now, oh, it doesn't. That's different. Let's do a rows. Okay. So we're going to delete all the rest of these, by the way. A rows is when you multiply the angle by a certain amount, right? So let's go 2. Like that. What if I go negatory? Ooh, that's interesting. What if I go 3? What if I go negatory? Ooh, you want to take it away?
Rotates 90 60.
Does it look like a propeller is moving? So that's the negative. Yes, it does rotate it. How does it rotate it specifically?
60 degrees.
Not 60. It reflects. It's a 180-degree flip. Thank you. All right. Winner, winner. Ryan gets dinner. So that negative,
It's not.
put that in there. That negative flips at 180 degrees from its orientation prior to being negative. Right, Adam?
Right.
You're going to check this out. You missed some details. Okay. 2. Now, the cool thing is we're done with limicons. We just knocked out the roses. And we've got all the classifications therein. And you know what that gives us time for?
Nothing.
Yes. We got to go backtracking.
Relaxation.
Before I backtrack, is there anything I can tell you guys about polar graphs that I haven't mentioned already? Is there something you're interested in, curious about?
Oh, you recorded all my wrong answers on there.
We probably wouldn't.
My name is Adam Rose.
And I missed. Yeah. Oh, there you go. Cool.